paid attention for a very long time. So in this case, if you visit me in the first place, I would already tell you all the story, all the background, and maybe all the possible future risks as well, side effects as well. So the lessons learned from this story was, even if the bug is not have to be fixed immediately, because you know all the bugs has not high priority. Sometimes we do the triage, and mark the bug with a low priority. So what we can do is we can just put it into follow list or maybe a watch list, and we can keep, right? But of course we have to monitor the side effects, because after some time it may raise some other issues as well. Because if we are not resolving the issue immediately, it doesn't mean that we can forget it forever. So yeah, it is likely that we are not resolving all the bugs immediately, because we have a lot of tasks in the meantime. We have some new feature implementations. We have already some bugs coming from the previous sprints, and we have very limited time, right? Most of us are working with agile practices, so maybe we have 1 week or 2 weeks, or let's say 3 weeks for the shippable product. So this time is very precious. Everyone is trying to be the first in the market. We are in a rush, and we are trying to implement some new features to deal with the rivals, to implement some new technology trends, and some new features may be requested by the customers. So sometimes bug will go into the next sprints. But of course, if we do not pay attention to them at all, maybe they will cause some trouble in the future. So this was the first story. The second story was, some bugs, we realized that some bugs were appearing and disappearing in the same time. Like, they were like a best friends band. Like, for example, if we miss some functionality on the gateway, we were having some security issues. Like, if we did anything wrong in the authentication or authorization functionalities, then we have some security issues. Or similarly, if we miss the load balancer functions, then we were having some performance issues. So these kind of relationships helped us a lot to avoid the bugs in the first place. Because if we don't want to have some performance issues, then we have to be careful about the load balancer functionality in the first place when we are doing the deployment. Otherwise, in the future, after the deployment, we will have some performance issues. Or similarly, if we miss or forget some functionalities in the deployment, then after going production, maybe we will have some security issues. And you know, these bugs happening after the deployment or going into production are much more costly, because finding them or fixing them in the first place is the ideal case. It's the best case that we want. Otherwise, it will be more expensive, it will be more difficult, because running code is already in the production environment. We will have to change the running code in the later stages. This we don't want. These we call general escape bugs, which were not found in time, but found in the production environments, or maybe reported by real users. So this is eventually a prestige issue as well, right? Real users or the customers are finding some vulnerabilities or weaknesses in our product. They are reporting. So this is a prestige issue for our company, for our project, for our product, for everything. And the last one is the sweet escape. Again, this is related to escape bug. Normally we want bugs to keep in our environments, we allow them, but sometimes the real users do not allow them. So we don't want bugs to go in users' environment. But somehow, one bug was raised in the user's environment, in the production environment. So when we talked to him, he tell us how he went to the production environment, how somehow he escaped from our environment. So the problem was, because you know, normally I'm designing some test cases to cover all the functionalities. Normally, I was thinking that I covered everything, but somehow, and apparently I didn't. So he told me what the problem was. The problem was, actually I covered everything, but not with the sufficient data set. Because you know, some functionalities should be compatible with lots of different data types. Both maybe the integers, double values, string values, or maybe different data values as well, not only data types, but the data values like negative values, positive values, corner cases should be compatible with everything. So testing only with a specific data type or data values sometimes is not sufficient to find the likely bugs. So all these kind of conversations that we made to bugs gave some lessons learned to us. So we tried to implement all these in our practices and life cycles. So we tried to avoid these kind of bugs in our future activities. So monitoring bugs can help us in two different perspectives. The first one is improving the quality, because if we find some vulnerabilities, we try to fix them. We try to remove the weaknesses in the product. This is improving the quality. On the other hand, we can collect lots of information about the health of our processes as well. How well we are performing our testing activities, or maybe development activities. I mean, the product itself is good or not, is with a high quality or low quality, whatever, but our testing activities or the development activities is how well performed. Maybe we are not doing all the testing activities, like testing activities, not only the functional testing, right? As you all know, there is performance testing, documentation testing, security, reliability, usability, lots of ability tests there are. So I will share some information we can collect from the bugs in the next slides, but there are lots of metrics that we can collect. But first of all, to be able to do the monitoring very well, we have some best practices. The first one is building a bug lifecycle. Because sometimes in our projects, there is a lifecycle defined. Like for example, for a regular task, let's say for an implementation tasks, there are some certain defined status, right? First of all, the defined status, and then active, in progress, verified, closed. This is a very simple lifecycle. But sometimes this is not enough for the bugs, because for bugs, we need some custom status as well. Like for bugs, it can be duplicated as well. It may be already reported by someone else, or it may be rejected, because sometimes we raise a bug, but they say that this is not a bug, this is a feature. As you all know, we face it a lot, right? Developers just say it's not a bug. It is as expected. And then what we can do, maybe we can discuss in the next slides. We can collect all the evidence if we believe that it is really a bug, because we are the advocates of the customers, right? If they say that it's not a bug, okay, close it. Maybe this should not be the case, but if we believe that this is really difficult for customers to use, we should support our claim. This is a bug. I mean, even if not a bug, this is a point to improve for the customers, for the users, because the usability is very important, not only the functionality, because they will use this product. It should be very easy and understandable and clear for them to use. So this kind of life cycle is very important, because otherwise, if we do not define them, we can mark, like, even if it is duplicated, we can mark as closed, it's still okay. But we will miss some information, right? In the future, if we want to monitor the activities, like how many bugs were rejected, if we don't have the rejected status, we will miss this information. Or how many bugs were reopened. If we want to collect this information, we will miss. So to be very visible and transparent, we have to build a good bug lifecycle, which is representing our real daily life activities. And next thing is the automated monitoring, because monitoring every day manually is not easy. We will open the website, we will do a query, do a lot of filters, run the filter, execute the filter, the query, and get the response, read it, parse the needed information. Doing everything is not easy. So what we can do is, once if I develop a code to perform this query automatically over the code, then I can run it periodically, right? I can define a job to schedule this job, like running every night, every morning, whatever, and it can already collect all the information for me. So in this one, maybe it's not readable anymore, but not important. In this one, what I'm doing is I'm just sending a query to the API. By the way, most of the servers that we are using for issue tracking, like maybe the most commonly used is Jira or something else, most of them have some open APIs. So you can do these kind of queries. So you can query, and here the code is doing, getting the list of all the issues, and for each of them, by iterating over them one by one, getting the creation date, what time it was created, and the resolution date, what time it was resolved. So if I subtract the creation date from the resolution date, what I will find is the time in between resolution duration, right? The time between resolution time and the creation time, resolution duration. So at what time it was resolved? Maybe in 1 week it was fixed, maybe in 2 weeks it was fixed. I don't know, we can track the time which was needed to resolve this bug. And the last best practice is, of course, utilizing the dashboards. Because numbers are great. Numbers are telling a lot of information to us. Again, if I go to this slide, this one, yeah, I will get a lot of data here, right? A lot of information. But it is not easy to interpret what's going on. But look at this. From the dashboards, I can have a lot of insights immediately. Like what percentage of bugs are still open, what percentage are still waiting for validation. Because you know, sometimes developers fix the bugs, but the testers still have to verify it. Because sometimes the fix work, but sometimes don't. So we have to verify and validate, and then close the issue. So this kind of visualizing the information helps a lot to understand really what is going on in our environments or processes. So after discussing this importance of monitoring bugs and the best practices, let's start talking about what kind of information we can collect from the bugs. So we can utilize lots of different graphs and dashboards. I will show you a lot of different types. Some of them are pie charts, some of them are line graphs, or some of them are tables. And all of them are on different dimensions. So the first example is distribution of bugs among their status and severity levels. But first of all, I have to make one notification, I think which is very important. Whatever we are tracking, I mean, the metric that we will use or track depends on our purpose, right? If you ask me, what is the best metric that I can track to get some insight from bugs? The answer would be, I don't know, because it depends. What is your purpose? Your main purpose is to reduce the escape bugs, or to improve the documentation in your process or project, product, or avoid the security issues. So first of all, the problem definition is very important. And then we have to define our purpose, what we are trying to do. And finally, we can define the related metrics. Like for example, for me, if the most important thing is resolve bugs as soon as possible, if this is my case, then I can concentrate only the bug resolution durations, right? So I can define the related metrics. So the duration, resolution duration itself is a very important metric, but there can be some other related metrics as well. So whatever we are tracking, first of all, it will depend on our purpose. And the second notification is, whatever I am tracking, the metric itself, only a single metric, may not mean anything. I mean, let's say I'm tracking the number of bugs I'm finding in each sprint. Let's say this sprint I found 3 bugs. And next sprint I found 10 bugs. The other sprint I found 30 bugs. So what can I understand from this? Maybe it doesn't mean anything, right? Because sometimes some people try to use these metrics like a performance criteria. Like this person found 100 bugs, this person found only 2 bugs. But it doesn't mean that the person finding 100 bugs is more hardworking than the other one, right? So, or maybe working more efficiently than the other one. It doesn't mean that directly. So we have to be careful. These metrics may not mean anything by themselves. We have to combine a bunch of metrics and make a comprehensive analysis. Try to understand what is really going on. So after this notification, this is just an example. This is the first one that I used in my project. The first one is distribution of bugs according to their status. What percentage of them were validated? What percentage of them were still open? Like they were just reported, but still not in progress yet. No one, it was assigned to no one, and it is waiting for triage. Or the other one is according to their severity level. In our project we have, I guess, 6 severity levels, but 5 and 6 were not real bugs, but the change requests. So we had 4 different severity levels, and for considering the severity, we were taking into consideration 2 different dimensions. The first one was the impact. How much impact will this bug have if it will raise in the customer environments? The second one is the visibility, or the likeliness, or the priority. Probability. So how likely customers will see this bug? Because sometimes it depends. It is a very trivial bug, like a typo in the header. So this impact is very, very low, right? But it is in the main page, in the title. So all the customers will see this. The visibility is very, very high. So sometimes to consider the severity, we have to consider lots of different dimensions. The most likely ones are the impact and the visibility, or the probability, but you can consider some other dimensions as well. Some teams are taking the complexity as well in terms of the implementation. I'm not sure if it is accurate, but you can consider some different dimensions. But after doing this triage, bugs will be classified under different severity levels. So I was monitoring this distribution over their severity levels as well. We were mostly finding high critical or high severity bugs or low severity bugs. We were showing in each sprint. Another example is we were showing the bugs according to the component or the microservice, because our product was a microservices product composed of lots of different services. So we were showing the bugs, distribution of bugs, on which they were found, on which component they were found. Like, if we have 20 different services, and let's say half of the bugs are coming from only one specific service. So what we can do is, maybe we can check, or we can talk to the relevant team, like, guys, most of the bugs are coming from this service. What's wrong with this? Are we missing some testing activities? Are we doing some deployment activities in the wrong way? So we can try to understand the root cause. But this may give some clues or tips for us to be careful about our testing activities or the development activities as well in the next sprints. Like maybe if there's a very certain service which is very prone to errors, then we may pay much more attention in the next sprints to that service. Another example, bugs per type. Like they are mostly functional bugs, or security bugs, documentation, reliability bugs. Because, again, reliability is also very important. Like, if you go to navigate to a page, you are getting, let's say, 500 error. This is we don't want to see, right? Internal service or server error. And if you refresh the page, it is gone. So you raise the bug, and developer says, it is working in my machine. That's the usual answer. So, but what we can do is, if we collect all the evidence, like maybe we can take a video, this may be an approach, or we can gather all the logs as well in the backend services. And if you collect all this kind of evidence and report them, this should be fixed. Because at the moment, if it is working, then we cannot forget this issue. If it happened once, it will happen again. And if customers will use it, it will be definitely a prestige issue for the product. And again, for our testing activities, it will be mostly in an isolated environment. It will not be under high load. But if we go into production, it will be much more likely to see these kind of errors. Sometimes we will get 5x6 errors, sometimes we will get 4x6 errors. So if we are seeing occasionally, we will still try to resolve these kind of issues. These were mostly the pie chart graphs that we can use. Another type we can use are the bar charts. For example, we can track the detection progress, right? For example, in this sprint, again, I thought previously we can track the number, but number itself may not give any insight. But at least it can give some tips, right? For example, when we are finding too much bugs, maybe after holidays, let's say, or after some heavy deployments. So these kind of insights we can collect. If we are able to manage or figure out these kind of relationships, we may take some action items. Like if the bug detection progress are always going higher, then we can already understand that we are not going well. After some time, we will have a huge burden, right? This will be a technical debt. There will be a lot of bugs open, waiting to be fixed. So if we realize that, this point, then we can stop our new implementation tasks. And guys, maybe it is time to first of all resolve all the bugs. Then we can continue with our new development activities. This we did in our project. Once customers started to complain, there are some bugs waiting. We are waiting for the new version. And you are implementing some new features. They are also very cool, but the bugs are more critical. So the product owners take the initiative to stop the sprint, stop all the new development activities, and first of all try to get rid of all the bugs. Because again, similarly as I told you a story in the beginning, even if they are not high criticality bugs, sometimes they will have some side effects. And after we have a lot of number of low priority bugs, then we will have some other issues as well. Because there are always open issues waiting over there, and if we do not get rid of them, they will have some other effects or impacts in the future. Another metric that we can track is the resolution duration. Like in what time we are resolving these kind of issues. So this will give us an idea to plan our resources, right? For example, if a bug, we need, let's say, 1 week with one person in average, then we can plan our resources. How many people I have in my team, how many bugs I should resolve in the sprint. Then according to my previous observations, I can do my planning. Of course, it may not be the average value, it may be a more tricky one to fix, or more trivial one to fix, but it can give me at least one prediction reference. I think this one is more insightful because the created or the number of created bugs or the resolution time themselves may give a tip, but this is more insightful, I guess. Because this will give us the gap between the created and the resolved bugs. So we can see the difference. So like sometimes these range are under control, we can say. But sometime over there, we started to see the gap in between created and resolved bugs. And at that point, we can do the sprint stop, stopping the implementation of new features, and first of all get rid of the bugs. And then again, maybe they will increase in time. And whenever we have to take some action item, we can consider various action items. And we can see the difference here in the below chart. And we can utilize some tables as well to consider bugs and their effects or their resolution durations under different classes. Like we can see if there is any open bug, open for a very long time, which we can call an old bug, like which is not resolved for 60 days. We may have lots of them, again, because maybe some of them are not high criticality levels. But if we distribute them among their severity levels, we can see if there is a critical bug, like severity 1, and still open, yes, there is one issue. So we can go and check why this issue is severity 1 and still open, not fixed for 60 days or more than 60 days. We can talk to the development teams, we can talk to the product owners. What is the issue here? Is there a blockage or is there an impediment to fix the issue? Otherwise, we can just create the tasks to get rid of this bug and assign the task to the relevant people. Or similarly, we can show the resolved bugs, but not validated yet. So waiting for the validation. This means the development team applied some fixes on the bug, but the tester should again assign it on himself or herself and do the testing activities, the verification activities. But it is not performed yet. So this time we can go to the test teams rather than the development teams and talk to them. There is two issues. It is very critical one, severity 1, and still not validated for more than 60 days. Why don't you validate this? If you validate and it is not working, please reopen this, because it is not reopened, it is in resolved status, but not validated. Or if you validate it and it is working, then close it, because otherwise we will always see these issues here. And one more thing to emphasize is the escape bugs. Again, I want to quickly remind you, because the impact of the escape bugs, which is found in the later stages, but not in the first stage, will be a real trouble for us. Because, yeah, finding the bugs as testers, or even for the development team members, finding the bugs and raising the issues are very important. But how about avoiding them in the first place? What if we didn't have it at all? It will be much more efficient, right? We won't be trying to get rid of these issues. So somehow, if we find ways to avoid them in the first place, this will be the most key factor to improve the efficiency in our activities. So somehow we have to be thinking from the customer's perspectives. We have to be seeing the product from their views, their eyes, and making enough empathy to understand their position. Because otherwise, if we think from the developer's perspective or the product's perspective, then maybe we may overlook some issues. Because think about it, you will be using this kind of features a lot of times before going to production, right? Sometimes they give you a product and want you to test it. You test a lot of times, and you get used to use this product. But for the customers, it will not be the case. They will be using for the first time. Sometimes they will struggle to find the buttons on the page. The page will not be that much clearer for them as it is for you. So sometimes it will be very difficult to understand. Sometimes the fonts are very small, but you are already get used to use it, to see it. You already know what text is there. So it is likely to overlook some vulnerabilities, all the improvement points, but we have to keep our concentration all the time and think from their perspective, not to have some escape bugs. So in the last part, let me share you a case study in which I try to classify bugs with the help of machine learning algorithms. So in this case, I used real data, collected bugs from my project. And in my project, there were almost 900 bugs, 900 reported issues. And again, there were 4 severity levels. But severity 1 was never marked to the bugs. because it was like human life issues. If there is a hardware in the project, if there's a current leakage, those kind of issues were supposed to be severity 1. So actually I had 3 different levels. So what I will try to do is try to predict the severity level of a bug into one of these 3 classes. Let's see how it works. Of course, my data here is text data, right? Someone raised a bug, someone defined a bug. He says like, when I do this query, I'm getting 500 response. This is the bug. There's a title, there's a description. So I collect the title and the description from Jira, from my issue tracking system, and then I train the data. I train the model. So a model is generated. So, and of course, first of all, there are some labels put by some human or CCB, like change board, change control board. Because sometimes, you know, you put severity 2 and then some people discuss it is not 2, it is 3. So the final decision is made by the CCV. So from the previous examples, there are already some definitions and the known labels. So I can generate a model from this, like, you know, machine learning is trying to observe the data and try to reveal some hidden patterns. Like most of the text, including 500, let's say, it's not rule-based, by the way, it is learning how it works. But as a very trivial example, if most of the text having 500 is marked as class 1, then it will tend to classify the feature samples which is having 500 to class 1 maybe. So this kind of hidden patterns machine learning will try to understand, because this is only one feature, but there are lots of different features. So first of all, I have to extract the features and generate my model. So the first step is pre-processing, cleaning the text, the redundant data, all the data that I don't need in the text, I'm removing. This is the first cleaning part. And then I'm extracting the features. The feature extraction is converting this text data to string into numerical arrays, right? Because PC doesn't understand the string values. Server returns me 500 response code. This doesn't mean anything to the PC. PC knows only zeros and ones. So I have to convert these sentences to numerical values. How I can do that? For this type of string recognition algorithms, an algorithm called bag of words is commonly used. This is based on the frequency of words. Like first of all the words coming from all the bugs are collected in a bag. This is my vocabulary. And in a specific sentence, which word happened how many times? Like in the sentence, the first word is happening once, the third word happening, let's say twice. All the others is not included in this sentence. So my vector will be 1, 0, 2, 0, 0, 0. So this is the way to extract the features. And after that, of course, the classification will be happening. So this is my data, distribution of my data. So as you know, most of the bugs were marked with class 2. So actually this is a tip already for me, because there is a bias here. If this kind of, there is a bias, means like there is not a good balance in the training data. In this kind of case, machine will tend to mark most of them with class 2, because in the learning, mostly it's so class 2. So in this distribution, my results were something like this. This is a confusion matrix. I can already see the bias here in the left upper corner. And the accuracy rate was 73% accuracy, which means normally a human raised this bug and marked with a severity level, let's say severity 2, 3, and then machine learning do an estimation, a prediction, And 72% of all the predictions made by the machine is accurate with the predictions made by the humans. I think this is not a good, this is not a bad result. But I can still remove this bias. How can I do this? I still have some time. So I can combine 3 and 4. This time it is much more balanced. Why am I doing this? Well, what's the relevance? Actually, it makes sense for me because, you know what? Class 2 was the release blockers for me. I mean, if I have a bug before I'm doing the deployment, if I have a bug marked with class 2, then it was the release blocker. I was blocking the release. Guys, stop, we cannot do this deployment, we have a class 2. So, deciding a bug will go to the class 2 or not is an important decision for me. So, in this case, I will try to decide a bug is class 2 or not. Class 2 or 3 or 4, whatever, the others. So, this time, sorry, this time the results were like this. So, it's much more balanced, and the accuracy rate was 82%. This is still good, but maybe not a perfect result, because it is a difficult scenario. You know, even among people, sometimes we are discussing. One person is saying this is 72, and I don't accept, I don't think it is 72, I think it is 74. Some other person thinks that it is 73. So sometimes it is very subjective. So it is a difficult scenario. And you know, sometimes we are discussing if the machines can replace us in the future. Maybe we don't need testers anymore, right? Machines can do our daily tasks. Because actually I have another talk in which I'm describing what kind of machine learning algorithms we can implement in our daily tasks, daily activities. They can do test definition. They can do test implementation. They can do test execution. They can do self-healing. Like if a test is broken, it can heal already the broken test. Or they can do the maintenance, like refactoring, or code review. If we can teach machines the best practices on the anti-patterns, they can already do the code review for me. These are all possible. But can machines replace us? The answer is no. Because why? Machines don't have emotions. The final decision should be made by the human. They can assist us very well. This result is very good for me. I can already do the first stage. I can let machines run to do the first prediction. And then I can do the final review. It will already increase my speed. It will help me a lot, but the final decision will be always on human beings. And another thing I can do is the clustering of the bugs, like generating some groups, similar groups, to manage in a better way the bugs, to figure out what kind of similar bugs I am having on my product. In addition to classification, I can do the clustering by the help of machine learning. So what we discussed throughout all the talk is we can collect lots of different information from bugs, but of course we have to be careful about our environment and our processes, our tools maybe. They should be very visible and transparent, otherwise I will miss some data, lose some information, and then I can collect lots of different metrics and information, but what kind of metrics will depend on my purpose and my problem definition. And instead of being stuck only on some specific metrics, we can collect a lot of them and do a comprehensive analysis, and maybe we can utilize machine learning as well to help us, to support us. So if there's any question, I think we have some time to discuss.